Nice to see you. So I am super proud to introduce Courtney McNatt, who not only managed to work with all of our students, but she managed to do it while having a baby at the same time, which is an unparalleled accomplishment. I don't think we've ever actually had quite that situation. So Courtney first started working in the education and public outreach group that I run last year, I believe. And she wants to be a physics teacher. So when it was time to do the capstone project, I said, how about if you do something that's we call an instructional design project, because that way you can continue to work with students, continue to learn more about teaching, and see what it would really be like to be in the classroom. And so that seemed to work well for her. And she had been already helping us with the Learning by Making curriculum, which has been developed with funding from the US Department of Education for the past 5 years. And so Courtney was able to adapt the curriculum to, which is normally done in the normal classroom during normal classroom time, to be more like a workshop, and to do that with a bunch of underrepresented students that are participating in a program called Academic Talent Search. So the plan was to work with more students after that, but then of course the virus hit, and so the plans had to be changed. But we're really proud of the work that she's done, testing out our materials, contributing to the design of the materials, helping us do a better job with next generation science standards with materials. And I'm going to let her tell you all about her work. So take it away, Courtney.
Okay, thank you, Dr. Kaminsky. Let's get this opened up. All right. Okay. Good afternoon. My name is Courtney McNatt. Again, I worked with Dr. Kaminsky on my project. So to begin my presentation, I'd like to bring everyone back to your high school science classroom. I know for a lot of us that might bring back some unpleasant memories, whether you were bored or stressed about it. It has a lot of negative association attachment for many students, and they don't ever want to have to take another science class again if they have a bad experience in high school. I personally had a bad experience with my science teachers in high school, but for me that didn't stop me from furthering my science education, but for a lot of other students it did. So I got motivated to want to replace my science teacher and do better, and I ended up landing working on this project, Learning by Making, created here at Sonoma State, and it makes learning science fun and collaborative and effective, and I wish I had it when I was in high school. So a national survey conducted was reported that 45% of high schools in the United States teach computer science classes, and 90% of parents wish that their children had the opportunity to have the ability to learn computer science in schools. So we all know that there's a big void in getting tech classroom concepts through. It's mostly just like textbook and lecture, same stuff over and over again. It's sometimes very expensive to have computer labs, etc. So we want to be able to kind of make our students and parents happy, but in the educational field, it needs to be adaptable and easy and cost effective. So we have this idea where we want to create a high school curriculum that integrates computer science, engages students, and gives them a fun way to learn STEM concepts. So to do this, we started with the next generation science standards, and we want to make sure that our lesson plans achieve the educational goals, obviously because there needs to be some standards to the material. It can't just be all fun and games. And the next important thing is that the students understand and they're interested in the material, and that they're learning the science behind all the fun experiments. And the last thing is we want to make sure that the teachers feel supported and that there's clarification to any problems that they come into contact with, mainly because we want to be able to make it easy for them to adapt it in a classroom setting, and they can lean on us if they have any problems, and they might be able to tell other teachers, hey, this is really awesome, let's get it in your high school. Okay. So The next generation science standards that have three main parts to it. The disciplinary core ideas are the main ideas in science that are kind of broad, that we want to make sure that the students understand. And then we go through, we want to make sure through the cross-cutting concepts that the students can connect between different science disciplines, such as like chemistry to physics, physics, engineering, etc. And the last part is we want to make sure that students kind of understand how science really works with designing experiments and kind of what it really is to be a scientist and what to do with data and build designs. So learning by making, it gives students the ability to do hands-on coding. They do a lot of problem solving. They work with breadboard circuit designs. Later on, there's collaborative projects, and then we work with real-world application experiment designs. It's mainly right now integrated at 9th grade, but it obviously has the capacity to be implemented in, I think, every level of high school. It's been under development for 6 years, and right now we are, it's at rural high-need high schools here in like the Bay Area. It's funded by the Department of Education. And previously, like Dr. Kaminsky said, my main role in learning by making was helping to go through material, find coding errors, find things that maybe needed clarification. I led, the voluntary student workshops on the weekends. That was really fun. I had a lot of fun with all the students, seeing them getting their LEDs to light up. I have a picture of that there on my screen. And they have a lot of fun putting these components on the breadboards and figuring out the problems in the code and getting them to light up. It's very hands-on, and the students have a lot of fun with it, and it's very satisfying to see them have their circuit board work. So a little bit more into the boards that we create. The students work with a microcontroller board called the Arduino. It's already plugged in for them, but they get to plug in the wires and the LEDs, resistors, to get it to work. The skills that they learn in the beginning of the material, they work up to being able to add onto their board, and they plug in sensors, and they're able to collect data with this board. And an example of the LED unit, which I think is the most fun personally for me, they get to light up the LEDs, so I have like a little design, they do red, white, green, blue, and then you can turn them back off. So that would be something that you would see a completed, coded project from a student. So the survey data that I collected from our weekend workshops to kind of see how this lesson plan is working in a condensed version, because it is traditionally taught in a high school classroom. We wanted to make sure that the students are still learning and having fun with the material in a shortened time frame. So some important features that I touched on in my survey, 40% of my group was female, 60% considered pursuing a STEM career after high school, 80% thought that the learning by making lesson plan made hard science concepts fun to learn, and 70% felt that they could learn harder concepts going forward. And the one thing I would like to touch on is that we want to know kind of where these students are coming from with science, if they already think it's too difficult for them to do, or they have this negative association with it because they had a bad experience with it previously. Half of them said science isn't really difficult to me and they're interested in learning it. However, this was a voluntary workshop, so perhaps if I had done the survey in the classrooms like I had planned, probably would have gotten a little bit of different data. So the last thing we touched on was we wanted to make sure that the teachers can go through the material and know how to solve their own problems and get this going in the classrooms, because it is a hard concept just in general, getting hands-on projects into a classroom, since you're normally just doing lecturing and you might have a lab, every other week. In this classroom setting with this material, the students are doing hands-on things all the time, and that can be a little daunting and scary with computers everywhere. The kids do different things with the laptops, they mess them up. So the pre-survey was done around I believe the first year of kind of getting this up and running, and the teachers were kind of unsure if they could kind of, do it themselves. But then a few years ago, then the post survey, they were really confident that that they made this material really easy to use for teachers in the classroom. And I think that's really important in getting this material in other high schools, because if it's hard to do, teachers aren't going to want to adapt it. So I think they did an amazing job working with teachers and having teacher workshops, and it clearly shows that we're able to get this material into classrooms, and it can be done, and it's easy and it's fun for both students and teachers. So the kind of overall idea is we improve the quality of our students' science education. We engage the high school students with hands-on coding experience with learning by making. The high school students will be more motivated to further their science education. This is a very important time for high school students because they're going to be making life decisions, whether they want to go to a job or a trade school or college. So they might be less intimidated to do so if they have a better experience in high school with science concepts. And therefore, we'll have more students in STEM programs, and our end goal is to have more professionals in STEM careers. And with that, I would like to thank Dr. Kaminsky and Dr. Pectolis for allowing me to be a part of their Learning by Making team, and I had a lot of fun, and I hope to see this in a lot more classrooms in the coming years. Thank you.
Well, that was wonderful. Thank you so much. We want to take questions. I see people are doing their applause, and that's what I was doing as well. I would like to say not everyone's familiar with these Zoom tools, but there are ways of raising your hand under the one of the activities in the participants. But why don't we take questions by people, whatever way, now that you've done your round of applause, whatever way that you'd like to get our attention with a wave, and we'll call on people to ask Courtney some questions on her talk. That's an example of me calling for attention. So Alex seems to have her hand up. Alex.
Courtney, first, a great job. It's really excellent hearing the refined version of your talk. Great work. So I was just curious, because you started in this direction because you were interested in teaching itself. Mm-hmm. But what you really did is physics education research, which is its own field. Like, people get PhDs in physics education research these days. So I was just wondering, after this project going forward, your plans are, like, are you going to get a teaching credential, or would you consider going towards research in education?
Yeah, so at the moment, I wouldn't be able to go right into a credential program. Right now, I'm actually working on if my husband's going to go overseas yet, not sure. But right now, I'm going to go to Southern California and live probably with my parents for a little bit, save up. But I would love to get a job in education with my degree now. Even if I worked in they have like those science boxes they send home, and they create like those cool packet things. That would even be cool for me. But I would love to teach, whether that's in a school or just, I don't know, I could do it on the weekends at like a YMCA or something.
Yeah, that's excellent. I think some private schools you can teach out without a credential even. So yeah, consider.
Very good. Do we have another question for Courtney? Any kind of hand gesture, reaction figure, or something in the chat? Maybe something from fellow students?
Well, this is Lynn Kaminsky again. I'm just going to say how proud I am of Courtney and all the work that she did, and the fact that she did all of this semester when she also had a baby is pretty amazing. And so I hope that when things settle down with the baby, she gets to go back and get to a credential program and ends up teaching, because I think she'd be a fabulous physics teacher.
Thank you.